Started with practicing with balancing, I'm going to give you some general rules that I tend to use to help guide me. Remember how I said the first thing you want to make sure is that your formulas are correct. So that's what I have up here. Make sure you have correct formulas, especially if the question gives you the names of all of the substances in words and you have to write the formulas. You've got to make sure you know how to write correct formulas. Okay. And then number two, balance the elements in the busiest substance first. What do I mean by busiest? Like the substance that has the most elements. So go with that first and try to balance all those elements in the chemical equation. You should balance elements that are all by themselves at the end. And you'll see that in a couple of the examples I'm going to give you. And then another rule says balance intact polyatomic ions as a unit. So for example, in this one, the NO3, just balance it as a unit rather than try to balance the nitrogens and the oxygens, just balance the NO3s. Okay? All right, so let's take a look. I see this over here looks busy. This over here looks busy. They're about equally busy. I see over here that there are 2 nitrates. Can you guys see that? And this one is 3 nitrates. So what you can't do is erase the subscript and change it and say, oh, I have only 2 nitrates. I need this to be 2. You cannot do that. What you should do when you see that you have, okay, 2 over here and 3 over here. So, oh, first of all, we got to make sure the formulas are correct. This is barium nitrate. This is correct. Barium's plus 2, nitrates minus 1. Perfect. Aluminum chloride. Aluminum's plus 3, chlorides minus 1. Yep, perfect. Aluminum nitrate plus 3, minus 1. Perfect. Barium chloride plus 2, minus 1 times 2. Yep. All the formulas are right. At least I hope they are, since I'm the one that wrote them. Okay, so back to the nitrates. You have 2 nitrates here. You have 3 nitrates here. If you put a 3 in front here and a 2 in front of this, this is 3 times 2 nitrates. That's 6 nitrates on this side. 2 times 3 nitrates. That's 6 nitrates on this side. You got the whole nitrates balanced. See how simple and straightforward that was? Okay, now take a look. You got 3 bariums. So if you have 3 bariums over here, you better have 3 bariums over here. So let's put a 3 here. Got my bariums down. Here you have 2 aluminums. So I guess we better put a 2 here. We got our aluminums. Now let's take a look. 2 times 3 is 6 chlorides. 3 times 2 is 6 chlorides. Boom, it's balanced. Okay? So there's a little bit of back and forth, and if you get frustrated, just leave it alone and then come back. Honestly, in this class, we don't really give you a lot of difficult ones. They're pretty straightforward. But remember these rules, and we'll do a few more. I'll give you a few more rules as we keep going. But let's put another one on the board here. Okay, I'm going to just get one from the book. End of the chapter, find one to do for you guys. All right, so these are really easy ones. I want to give you guys something a bit, okay, I'll do that. Okay, I'll get to those in a little bit. Let's do the, okay, sodium carbonate and magnesium nitrate. So sodium carbonate and magnesium nitrate. Is going to give you magnesium carbonate and sodium nitrate. So magnesium carbonate and sodium nitrate. I'm so sorry it's so squished. This is ridiculous, but hopefully you can see. This is really easy to balance. Take a look at it. The formulas are correct. Sodium's plus 1, carbonate's minus 2. This is correct. Oh, I got to put a 2 here because nitrate is minus 1. Okay. This looks super busy. You got 2 nitrates. You want 2 nitrates over here. So you're going to put a 2 in front right over here. Never put it in the middle, put it on the front. So we got our nitrates done. And when you put the 2 here, you have 2 sodiums, and here are 2 sodiums. So that's perfect. And you know what, guys? It's already balanced. This is a really easy one. You have 1 magnesium, 1 magnesium, 1 carbonate, 1 carbonate. The beauty of these things is that if the formulas are correct, you will always be able to balance it. No difficulty whatsoever. Okay? All right, now let's kick it up a notch. Let me show you what to do when you have a hydrocarbon combustion. Hydrocarbon combustion is when you've got an organic molecule that's got carbons and hydrogens in it, and you are going to burn it in oxygen. You'll always get 2 products, carbon dioxide and water. So let's say you've got this, C3H8, which is propane if you're grilling. This is the propane gas. Plus oxygen will give you carbon dioxide and water. Okay, so remember the rule that said start with the busiest compound. This looks busy right over here, okay? And remember the rule that said balance the element that is all by itself at the end. So the last thing you're going to balance is this O2 by itself. Don't even try to balance this until the end. So let's focus on the propane. You see you've got 3 carbons. So you want 3 carbons on the other side. Let me do it in red so that you can see the differences here. So I want 3 carbons. I got my carbons done. Everybody can see that? Okay. 3 carbons here, 3 carbons here. All right. I have 8 hydrogens. I already have 2 hydrogens, so I need to multiply it by 4 to get 8. That's all multiplication, not addition, guys. Okay. So my carbons are balanced, my hydrogens are balanced. Now, this is what I need to balance. So I come over to this side and I see how many oxygens do I have over on the right. So this is 3 times 2 is 6, plus 4, you have 10 oxygens. All right, so if you have 10 oxygens here, you want 10 oxygens here. You already have 2. What do you need to multiply by 2 in order to get 10? 5. Perfect. Everything is all balanced. Okay? Kick it up one more notch. Okay. Let's say you have butane, C4H10. Butane is the gas that is in the Bunsen burners in the lab. Okay? So butane plus oxygen, again, it's a hydrocarbon. It will also produce carbon dioxide and water. Okay, so we're going to use the same technique that we just used with the propane, but this one's going to be a little different. So we have 4 carbons, so put a 4 here, got the carbons done. We have 10 hydrogens, so you're going to have to put a 5 here, got the hydrogens done. Everyone can see that. Okay, remember how this is going to be the last thing we balance. Any element that's by itself is always balanced at the end. All right, so let's count how many oxygens we have over on the right. 4 times 2 is 8, plus 5 is 13. Everybody see that? You take the subscript 2 times 4, so you have 8 oxygens plus 5 oxygens, a total of 13 oxygens. So I want 13 over here. Notice that if you put 13 here, that'll give you 26. Can you see that, guys? Because you're supposed to multiply by the subscript. So if I put 13 here, that gives me double what I want. It gives me 26 oxygens. I only want 13. So this is another rule, maybe rule number 5. Use fractions if necessary. What do I mean? Let me divide this by 2. I've just put a fraction, an improper fraction here. You're allowed to do that with these types of chemical reactions or chemical equations when you're balancing it. Use fractions if you must. The only thing is you can't leave it. You can't leave a fraction. So You did 13 over 2 because 13 times 2 is 26, divided by 2 is 13, so that's the 13 oxygens you want. What you have to do, if you're going to use a fraction, you have to multiply all the coefficients by the denominator in order to get rid of the fraction. So you take this whole equation and multiply it by 2. Why by 2? Because I want to get rid of this 2. So 2 times 1, by the way, if you don't see a number in front of a substance, that means the coefficient is 1. Don't ignore that. It's still a 1. It's 1. So 2 times 1 is 2. So go 2C4H10 plus 2 times 13 over 2 is 13, because the 2's will cancel. 13O2 will give you 2 times 4 is 8, 8CO2, plus 2 times 5 is 10, 10 H2O. And you can check, it is perfectly balanced. Okay.